Good morning, my dear students. In the last class, we have discussed about the accelerators. There are two types of the accelerators. One is the linear accelerator, another is the cyclotron. In the last class, in detail, we have discussed about the linear accelerator. First of all, what is the meaning of the accelerator? It is a device which is used to increase the energy of the charged particle. In case of this linear accelerator, how the energy of a charged particle can be increased, but in detail we have discussed in the last class. Now, in this linear accelerator, there is a drawback is there. Then one thing is, since the energy of the charged particle is increased by passing through a hollow cylindrical tubes which are increased in the length like this. Then these hollow cylinders, they are kept in a long vacuum tube, isn't it? So therefore, these cylinders are kept in a linear manner, isn't it? Then, practically, in order to increase the charge energy of the charged particle, we require a number of what is the cylindrical tubes. Then the size of this linear accelerator is very high. And practically, I will mention you that this size of the linear accelerator, it is of length of few kilometers, isn't it? It is not a small. Therefore, in such a so much length of the cylindrical the tubes, maintaining the vacuum, it is a very, very difficult task. This is one drawback. Second drawback is due to the motion of the charge, whatever the current is produced. Yes, you are familiar that electric current is what? The rate of flow of charge. That means whenever the charge is in motion, that motion of the charge produces the current. Then the charged particle, when it is moving with a high speed, then a tremendous amount of current is produced. Then maintaining or controlling that current, it is also being a very difficult task. These are the two main drawbacks of the linear accelerator. One is it is of very big in size, isn't it? Second is the maintaining the vacuum in such a big length of the tube, it is a very difficult task. And the third is that due to the flow of the charge, with the high speed, whatever the current is produced, maintaining or controlling the current, it is a very difficult task. Now, these are the three drawbacks or difficulties of the linear accelerator. In order to overcome these drawbacks or difficulties, then one more accelerator it is developed. This is cyclotron, isn't it? Now, let us try to understand then in this cyclotron how the energy of the charged particle can be increased. Now, step by step, let us try to understand. The first thing is in this cyclotron, the main purpose of developing this cyclotron is to reduce the size of the accelerator. Isn't it? Linear accelerator, it is very big in size. That means I have mentioned you that the length is of a few kilometers. Isn't it? Therefore, then we want to reduce its size. Then how to reduce it? Or in a linear accelerator, why so much length it is? They are required? The reason is that the charged particle is moving in a straight line, isn't it? So that then it has to travel in a straight line till it gets the required amount of energy, isn't it? Therefore, it requires a very or it has to travel a very large distance to gain the required amount of energy, so that the size will become very large. Now we want to reduce its size. How means? The one method is, instead of making to move the charged particle in a straight line, if we make it to move in a circular path, then the size can be reduced. This is a method which is adopted in reducing the what is the size of the accelerator, then that principle it is adopted in a cyclotron, isn't it? Then here the first what it is the concept is that we want to move the charged particle in a what is circular path, not in a what is a linear path. Then the question is that how to move the charged particle in a circular path. I think in the third or fourth semester, you might have studied that in case of the magnetic effects of electric current, what means when any charged particle is passed through the magnetic field, that it moves in a circular path. Isn't it? Now let us consider here, this is a charged particle, isn't it? Moving in this direction. Then when you apply the magnetic field perpendicular to this one, then the charged particle it moves in a circular path. Instead of, or if there is no magnetic field, it will move in a straight line. When you apply the magnetic field and that to the perpendicular to the direction of the motion of the charge, then this charged particle will move in a circular path. Isn't it? Now, in the lower classes, you have studied that if any body wants to move in a circular path, it requires centripetal force, isn't it? Then, because of the application of this magnetic field, the charged particle it is moving in a circular path means now this circular path requires the centripetal force, isn't it? Now, the question is that from where this charged particle gets the centripetal force, isn't it? Here what will happen is when the charged particle moves through the magnetic field, then the force will act on it, isn't it? That is, when charged particle moves in the magnetic field, then the force will act on it, isn't it? Then what is that force formula in the third or fourth semester you have studied? Just I will recall that formula. F is equal to QVD, isn't it? Q means what? It is the charge of the particle. V is with what speed it is moving, and B is the applied magnetic field, isn't it? Now this much amount of force will act on the charged particle in the magnetic field B. Now this force it is used as the centripetal force to move the charged particle in a circular path. Now the centripetal force formula is what? Centripetal force is what it is the this force it is used as a centripetal force means centripetal force is equal to mv square divided by r. Now this is a very important equation which is used in the discussion of the theory of the cyclotron, isn't it? Now from this equation, isn't it, V will get cancelled. Now this Q into V it is equal to mv divided by r, and the r it is equal to mv divided by q into v, isn't it? That means if the charged particle moves in a circular path, means then the radius of the circular path it is equal to mv divided by q into v. Then mass of the particle, velocity of the particle, charge of the particle, and v is the applied magnetic field, isn't it? Now see, this is the method what is adopted in a cyclotron to reduce the size of the accelerator, isn't it? Now, after understanding, isn't it, this one, and one more point, important point, what we have discussed in the previous class, that this is the distance traveled, it is equal to velocity into time, isn't it? We have discussed it in detail, but still again I am recalling this one. Then to maintain the same time, what will happen? It is a constant, then the distance is proportional to the velocity. That means to maintain the same time, if the speed increases, then it has to travel the more distance, because these two are directly proportional, isn't it? Distance it is proportional to the velocity when you maintain that time as a constant, isn't it? Now that means, once again I am repeating, to maintain the same time, isn't it? If the body moves, isn't it? If the speed of the body increases, then it has to travel the more distance to maintain what it is a constant time, isn't it? This is now with the help of what it is these two visiting the informations, we will discuss what it is in detail about the construction theory of this cyclotron. Now, from here onwards, you should be little bit careful. Now here, first regarding the construction of the cyclotron. Here, it consists of the two, what it is the semicircular metallic discs D1 and D2. That is, it consists of two semicircular, the hollow metallic discs. Now, see, this is a disc, let us consider like this one. Is it a? Then inside it is what it is a hollow. It is not a solid one. Now, these two, what it is semicircular metallic discs, they are represented as D1 and D2. Now, these two discs, they are connected to the what it is the high frequency oscillator. Then what is the oscillator? That we are discussing in the linear accelerator. Now, these two, what is the discs, they are placed between two powerful magnetic poles, isn't it? North pole and this one. But with the help of this, what is the magnetic poles, what they will do? They provide some required magnetic field, isn't it? Now, here, this is it's a construction. What it is? It consists of two semicircular hollow metallic discs, D1 and D2. These two are connected to the high frequency oscillator. These discs, they are placed between two powerful magnetic poles, North pole and South pole. This is the construction of what is the cyclotron. Now let us come into what is the theory. Now here, this is a source of charged particle, is it or ion? It is placed at the center between the two Ds. This is the source of a charged particle or a ion. Now, now these two, the two Ds, they are connected to a high frequency oscillator. And we have to know that at any instant of time, if this is positive and this is negative, then after every half a period, the polarities will be reversed. That is what we have discussed in the linear accelerator, isn't it? The polarities of the two discs will be reversed in every half period, isn't it? Now, at any instant of time, if D1 is positive and D2 is negative, then after completion of the half of the periodic time, this will become as negative and this will become as a positive. This is the principle. Now, let us try to understand here. A source of charged particle or ion is placed at the center between the two Ds. Now, when this source emits a charged particle, whether it is a positive charge or negative charge, whatever you require. Now, let us consider for our understanding, this is a source of negatively charged particle. It emits negatively charged particle. Then as soon as it emits, doesn't it? The negatively charged particle at any instant of time, is it? D1 is positive, isn't it? Then and D2 is negative. Now when D1 is positive, since this is what it is that emits a negatively charged particle, hence that negatively charged particle is attracted towards the positive. Then this what is the particle? It will enter into the what is the disk D1 because it is positive. As soon as it enters it, isn't it? As soon as it enters it, what will happen is, since it is subjected to the magnetic field, therefore it moves in a circular path. It moves in a circular path. Now, what will happen is, as soon as it reaches to this point, it will take some time. Isn't it? It is so adjusted that the time taken by the charged particle to travel this what it is the semi-circular distance, then that time it is exactly equal to half of the periodic time. Isn't it? Time taken the charged particle to travel this much distance, it is equal to what? It is equal to half of the periodic time. Isn't it? Now, as what it is the time reaches to the half of the period, then when it reaches to this point, immediately the polarities will be reversible. Okay. When the polarities are reversible, then what will happen is now this becomes negative and this becomes positive. Okay. Then when it reaches here, now it will become positive means now this negatively charged particle is attracted towards D2. Okay. Then when it is attracted means what? It gains the energy, means its speed increases, isn't it? Then when it is entering from D1 to D2, it gets attracted. The speed increases, isn't it? As its speed increases, what will happen is again it is subjected to the magnetic field, means what? It moves in a circular path of greater radius. Means what? It is traveling the more distance now. Why? Already I have told you that, isn't it? To maintain the same time, if its speed increases, it has to travel the more distance. Then, therefore, why it is what a charged particle is entering from D1 to D2, it gets attracted means its speed increases. Then, since its speed increases, to maintain the same time, it has to travel the more distance. Again, when it reaches to this point, that time when the charged particle to travel this much distance is again equal to half of the periodic time. The polarities will be reversed again. Now this will become positive, this will become negative. Therefore, what will happen is this charged particle gets again attracted. Isn't it? When again it is attracted while it is coming from D2 to D1, then its speed again increases. Isn't it? When its speed increases, to maintain the same time, it has to travel the more distance. Again, when it reaches to this point, time is equal to half of the period. Again, the polarities will be reversible like this one. Again, it is gets attracted towards D2. Then when it is attracted means what? Again, its speed increases. Then to maintain the same time, it has to travel the more distance. Now, this process will continue like this one. As a result of which, the charged particle moves, is it in a circular path of greater and greater radius as its speed gradually increases. Now see, its speed gradually increasing is nothing but its energy also gradually increases. Isn't it? Because the energy formula is what? Energy is equal to half mv square. Isn't it? Therefore, yes, its velocity increasing is nothing but the energy will also increases. Now here, when the particle gains the maximum energy, isn't it? The particle gains the maximum energy when the charged particle reaches to what it is the edges of this thing. Isn't it? In the beginning, speed is less, therefore it travels the less distance like this. Isn't it? As it is moving in this circular paths of greater and greater radius, the speed is increasing, means its energy is also be increasing, and the charged particle gains the maximum energy when the charged particle reaches to edge of the disk, isn't it? Then here there is an opening is there. Now after gaining the charged particle the maximum energy, then here a suitable deflector it is placed, isn't it? Suitable deflector. Then suitable deflector means what? Since if it is what it is a negatively charged particle, we use a positively charged deflector. Right. Now, since this is negative and positive, then when it reaches to this edge, and because of the attraction, it will come out. Then as soon as it comes out, then here the any nucleus it is placed, isn't it, in which the nuclear reaction is to be caused. In whatever the nucleus we want to cause the nuclear reaction, that nucleus it is placed here. Then as soon as it comes out through this, what is the this, then immediately it hits to this nucleus, then the nuclear reaction will stop. Now see, this is the way, isn't it, how the charged particle or how the energy of the charged particle can be increased. Isn't it? Now see, this is what the theoretical explanation. Isn't it? Now let us come to the mathematical what the theory in this one. Now here, yes, already I had mentioned that The charged particle it is moving in a circular path means any body, if it wants to move in a circular path, it requires a centripetal force, isn't it? Now that centripetal force, it is provided from where? It is provided from the force acting on the charged particle due to the magnetic field, isn't it? Now here, this is nothing but force acting on charged particle due to the magnetic field is QVB. This and this what is a force? It is used as a centrifugal. This is equal to formula is what mv square divided by r. This one. Now from this will get cancelled. Now r it is equal to what will is r is equal to from this equation mv divided by this is q into v. Then that means here looking to this equation, is it you can understand that. Then here what is r use? R use it is the radius of the circular path in which the charged particle is moving. Mass of the particle, velocity of the particle, then charge of the particle and applied magnetic field. Now here this complete it is a constant. Why means because mass of the particle is constant, charge of the particle is constant, then by using these two magnetic, what is the force, whatever the amount of magnetic field you are applying, that is also be a constant. Now when this complete it is a constant, you can see that R is proportional to V. That means this mathematically we can explain that as the speed is increasing, the radius of the circular path also increases. Isn't it? That means its meaning is that when you look at here, when the speed is less, then it will move in this circular path of this much radius. Okay. Now, if the speed is increasing, then as it is coming here, its speed is increasing, then what will happen is, as its speed increases, it moves in this circular path of this much radius. Like this one. As the speed is increasing, the charged particle it is moving in a circular path of greater radius. Now, this is the way how we can explain mathematically also. Then, here, time taken by the charged particle to move circular path is taken. Now, you know that the formula distance is equal to velocity into time. Correct? Velocity into time it is. Now, this time it is equal to distance divided by velocity. This is equal to. Now, when it completes this, what is the semicircular path? The distance is equal to how much it is up? Half of the circumference. When it completes one circle, distance is equal to circumference of the circle. When it completes half circle means the half of the circumference by r. Then this is equal to divided by v. Now this is equal to r. It is equal to how much? This is now we can see that this is m. Is it v divided by mv? Is it pi first? This is equal to pi. V is equal to r. Nothing but mv divided by q into b into this. Okay. Now this pi I have written as it is, instead of r I have written mv divided by q into b, then this is v. Now this is equal to. Now therefore this is the time. Now speed it is equal to pi m divided by q into this. Now the time taken by the charged particle to complete the semicircle is equal to this speed. Now you have to know that this time is taken. The time it is must be equal to what? Time taken to complete semicircle, it is equal to half of the periodic time. Then here usually periodic time it is represented by capital T. Is it half of the periodic time is what is the T by 2. Therefore, this is small t. Is it what it is? Time taken to complete semicircle. It is equal to half of the period. This is T by 2. Now, instead of this T, you substitute this much. Now you will get it here. This is pi m divided by q into b is equal to T divided by 2. Is it? Therefore, from this equation, this capital T, that is a periodic time, it is equal to, what will happen is cross multiply here, 2 pi m divided by q into b. This is periodic time. Next, yes, you know that frequency is equal to what? The reciprocal of the periodic time. Isn't it? Now, yes, you know that f is equal to 1 by t. Isn't it? Now you take its reciprocal. This is equal to qb divided by 2 pi m. Isn't it? Now this gives, it is the frequency of this motion of the charged particle. Frequency of motion of the charged particle. Then one more, is it a important points I want to make it clear. Is it here? Then you know that Q is equal to what? Q is equal to charge of the particle. If you have used the electron, okay, charge of the electron. B is what? Applied magnetic field. Then how much magnetic field is it you have applied? That is known to you. 2 pi is a constant. M is mass. Is it? If you have used the electron, then substitute mass of the electron. Now after substituting all these, is it Q value, B value, M value, you will get some frequency. Is it? That is, the frequency is nothing but what? Frequency of motion of the charged particle. Is it? Then whatever the frequency, you will get it here, value, frequency of motion of the charged particle. Then you have to apply the same frequency from this oscillator. And then oscillator means, I have told you that, which provides the AC of definite frequency. Definite frequency. Then should not be confusion. Oscillator means, don't think that then what is signal generator, isn't it? Whatever we are using in the laboratory, then they, you have seen that, isn't it? Using that signal generator, you can apply what is the any frequency, isn't it? In what it is, the hertz is there, kilohertz is there, isn't it? All of you are seeing it. Then whatever the frequency of AC you want, that much what it is the frequency of AC you can apply by using it. Therefore, now what you do is, then depending upon which what is the particle used, isn't it? On the basis of that, you put the charge, applied magnetic field, mass of that particle, calculate it. Then after calculation, whatever the frequency value you get, then what you have to do is the same what is the frequency applied from this what is the signal generator. Isn't it? Now, when the frequency of motion of this charged particle is exactly equal to the frequency of this AC, then only what will happen is when these two are matched, then only what will happen is then the particle gets accelerated, isn't it? Otherwise, what will happen is then when these two frequencies are matched, then only what will happen is time taken to complete half circle is equal to half of the periodic time, isn't it? Then if the frequencies are not matched, then what will happen is then time taken with the charged particle to complete half of the semicircle will not be equal to half of the period of phase. Isn't it? Because if the frequency of this and the frequency of this are not matched, then this type of the difficulties will arise. Isn't it? Then as a result of it, when these two frequencies are not matched, in such cases, what will happen is the particle, instead of accelerating, it starts deaccelerating. In this point also, you keep it in your mind. Isn't it? That is, here the frequency of the oscillation or rotation of the charged particle must be exactly equal to the frequency of your AC. Then only the particle will be gets accelerated. Otherwise, no. Isn't it? This one. And the next is here the question. When it reaches to edge of the D, what is the gains? What is the maximum energy? It gains the maximum energy, isn't it? Then let us see here how much amount of energy is it, or maximum energy it is gaining, isn't it? Now from this equation, you can take it here or you can calculate that. Let us represent this equation number as 1, isn't it? Now from equation 1, isn't it? Then V is equal to what you get it here? Velocity. Then you what is the R cube B divided by M. Now this is equal to, you will get it here, Q B R divided by what it is a M. This is what you get it here. Now this is the velocity when radius equal to r, isn't it? That try to understand when the particle is moving in this semicircular path, this one is the radius. Now in this radius, isn't it? What is the velocity? Now suppose when you take this much radius, in this radius of the circular path, what is its speed? Then you will get. Yeah, increases, isn't it? The radius is increasing, its velocity it is be gradually increasing. When it gains the maximum velocity, when the radius is maximum, isn't it? Now this V maximum it is equal to here Q B R maximum divided by M. Isn't it? Now what may be the maximum radius the charged particle? What is the occurrence? Isn't it? When it is moving in this one is the radius. When it is moving in this one, maximum when it reaches to, isn't it, the charged particle here at the edge, isn't it? Then that is the maximum radius. Isn't it? That maximum radius it is exactly equal to what? When it moves here, then maximum radius of the charged particle is equal to what it is? It is equal to radius of this what it is d, isn't it? Maximum radius of the circular path in which the charged particle is moving is exactly equal to what it is the radius of the d is. Now, when V is maximum or is maximum, then E maximum it is equal to how much maximum energy it gains. Maximum energy gain it is equal to what it is, the formula is half m V maximum square, isn't it? This one, because when the velocity is maximum, energy is also be maximum. Now this is equal to here half m, isn't it? V maximum it is equal to this much, isn't it? Then here Q B, isn't it? R maximum divided by how much it is m. Then square is there. Now I will write it, isn't it? Now here once again, this is equal to what I will write here half m. This V maximum is nothing but it is Q B R maximum divided by m, and square is there, so that I will write it here as a what it is the square. Isn't it? I think I will. It is better. I will write here. E maximum it is equal to here half m V maximum what is the square. Now this is equal to half m V maximum value it is equal to how much it is Q of B R maximum divided by m square it is, isn't it? Now this is equal to, when you simplify this one, you will get this into this Q square or B square R maximum square divided by R maximum square divided by what it is m square. Now again, when you simplify this, I will arrange this one. Now this is equal to here half is it 8. This I will write. Now this what is the m and 1 it gets cancelled. Then what we get here is Q square B square R maximum square, isn't it? Divided by, you will get it here as m, isn't it? This is the E maximum value. Now let us represent this equation number as what is the 2. Now this is equal to, then I want to express this maximum energy in terms of what the frequency. Now here, let us see how can we express this energy in terms of frequency. Isn't it? Now, let us write this q square. Isn't it? B square already it is there. Isn't it? R divided by. If I write like this, it is a 4 pi square. Isn't it? M square. Here, then this is equal to what you get here is R maximum, it is value. Then here R maximum square, you put it this as it is. Now this, what is the equation? If we want to express like this one, then additional what you will write, it is what it is the 4 pi square. Now I will take this as 4 pi square. This is it. And 1 m is there. This is it. Then now R maximum square is or maximum. Now you see that here this 4 pi square, this 4 pi square will get cancelled. Is it? And next 1 m of this will get cancelled. Is it? What we left? Then q square or b square. Is it? And what it is the R maximum is there. Is it? If 1 m of this will get cancelled means m. Then 4 pi square will get cancelled. Therefore, this equation we can write like this one, so that I want to express this equation of maximum energy in terms of what is the frequency. Now this is equal to, is it? Now what will happen is this 2 and here you get. Therefore, what we get here is 2 pi square. 2 pi square. Next is you are having m. Is it? And this complete, is it? You can make it here as what is the f square is. Then this complete, you can write this as what is the f square. Because f is equal to what? This is it q b divided by 2 pi m. Then square this one you get q square b square divided by 4 pi square m square. Therefore, now you can write this as what it is the f square. Is it? And remaining is what it is the R maximum square. Is it? R maximum. Therefore, this is the value of E maximum. Okay. Now here you can see that all the values are known to you. Is it? M is what? It is the mass of the charged particle which you are using, and F is what? The frequency. Is it? How much frequency you have applied from this AC, and this R maximum. Is it? Maximum radius. Is it? Of the circular path in which the charged particle moving. That maximum radius, it is exactly equal to, I had to do that, it is equal to radius of this circular D. Is it? This is the circular D you have used, and its radius is nothing but it is the maximum radius. Is it? Now that all these values you substitute it, is it? Then you will get how much, is it? Maximum energy it gains. Isn't it? Now this is the what it is the formula for the calculation of the maximum energy gained by the charged particle. And next the question is that, yes, be what is serious here to understand this point. Then you are observing that yes, the particle moves in a circular path of greater and greater radius, its velocity increases and its energy also increases. Doesn't it? That is, the particle moves in a circular path of greater and greater radius, energy is also be gradually increasing. That means from this equation, this complete it is a constant. This means then mass of the particle, how much frequency you are applying, that is also be a constant, and this E maximum, it is proportional to R maximum square. Isn't it? E maximum is proportional to R maximum square. That means this shows that if you want the maximum energy, or if you want the more energy, then you have to select the circular D of greater radius, isn't it? Then if you want less energy, then you select the circular D of the less radius. That means the size of the circular D's whatever you are using, it depends upon the energy it is. How much energy you require, isn't it? If you want the charged particle of more energy, then you use the circular D of greater radius, isn't it? If you want a charged particle of less energy, you select this what it is the circular D of less radius. Means the size of the D's, isn't it? Depends upon the energy, isn't it? Depends upon the energy. Then what will happen is the serious reason here for if you want to get a definite amount of energy of the charged particle, you have to select the circular D of definite radius only, isn't it? You cannot take the circular D of any radius randomly, no, isn't it? Because then suppose if you use less radius, if you want more energy, then if you use the circular D of what it is the less radius, will you get it? No, isn't it? Then if you want more energy of the charged particle, then you require the radius of the D should be more. If you want less energy, then you require the circular D of less radius. Means for a definite amount of energy, isn't it? You need a circular D of definite radius only, isn't it? Then how to get the idea, isn't it? How to get or how can we understand that for this much amount of energy, we need the circular D of this much radius only. Then that you can calculate by using this what is the formula, isn't it? Now what you have to do is then how much amount of energy you require, isn't it? On the basis of that only you have to select the circular D of that particular radius, isn't it? Therefore, from this equation, isn't it? R maximum square, isn't it? R maximum square means what? What is the maximum radius of this one? Isn't it? Yes. Then this is equal to what we get from this equation, this E maximum divided by this complete factor will comes to denominator. This is 2 pi square. It is m into what it is the f square. Now this R is equal to what we get it here? The square root of this one. Now what you do is how much amount of energy you require, that is substitute here. Then 2 pi, it is constant. M is what? Mass of the particle. Suppose if you are using the electron, then use what is the mass of the electron, substitute here. And F is what? F means how much frequency you have applied from this signal generator. That is also been known to you. Isn't it? Then here you substitute all these values, then you simplify, then you will get what is the radius. Isn't it? Then what you do is you take the circular D of that much radius, isn't it? And whatever the frequency is it, you have substituted that much frequency you apply from this signal generator, then you can see that charged particle after what is moving into this what the circular D is, when it comes out, it gets this required amount of energy, isn't it? Therefore, this is the way, isn't it, how we can increase the energy of the charged particle in this cyclotron, isn't it? Now, here the main advantage of this cyclotron over the linear accelerator is that in this size of the cyclotron, it is very what it is much less than what it is the size of the linear accelerator, isn't it? And here, since it is moving in this in a circular path, it is moving in a circular path, then controlling the vacuum in what is the small size of this cyclotron, it is not that much difficulty as in case of what is the linear accelerator. That means whatever the drawbacks, isn't it, in the linear accelerator are arised, then to the maximum extent, isn't it, we can what it is the avoid those what is the difficulties in this what it is the cyclotron. I think all of you might have what it is understood this what it is the principle, construction and theory of the what is the cyclotron and what is the advantage of this cyclotron over what is the linear accelerator. Now I will stop here. The next point we will discuss in the next class. Thank you. Thank you.